Okay, guys, we're going to start talking about periodic functions. This is part number 2 of the tide or the depth of water as it relates to periodic functions. So we have a group of RHS students decided to study the sinusoidal nature of tides. Values for the depth of water level were recorded at various times. At x equals 2 hours, low tide was recorded at a depth of 1.8 meters. At x equals 8 hours, high tide was recorded at a depth of 3.6 meters. We want to sketch the graph of this function and write a cosine equation expressing distance in terms of time. And then we want to give the depth of the water, or the approximate depth of the water, at x equals 21 hours. So the first thing we need to look at is the information we have from this problem. We have at x equals 2 hours, low tide was recorded at 1.8 meters. So that means our minimum is 1.8. And at x equals 8 hours, high tide was recorded at 3.6. So that means our maximum is 3.6 meters. And then we have the horizontal shift here as well, because the time of the first maximum that's recorded is our horizontal shift, and that is 8 hours. So here's the information that we have, and here's the information that we need to use in order to figure out the rest of this problem. So we can take the maximum, and we can have it by taking max plus min divided by 2. And if we add 3.6 and 1.8 and divide it by 2, we get 2.7. The amplitude can be found by taking the max minus the min and then dividing it by 2. We'll get 0.9 whenever we find the amplitude. The last thing that we need to find is our period length. Well, our period length is the time it takes from the maximum. It's 2 times the time from minimum to maximum. Well, the time from minimum to maximum is 6 hours. It shows here 1.8 meters was our minimum. That happened at 2. And then at 8 was our maximum. So 2 away from 8 is 6. So our period length is 12. Now we can find our A, B, C, and D. Well, A is our amplitude, so that's 0.9. C is our horizontal shift, so that is 8. D is our axis, which is 2.7. And then we can also find B by taking 2 pi divided by our period. So we have 2 pi divided by 12, which equals pi over 6. So now we have our A, our B, our C, and our D. And now we can insert A, B, C, and D into our equation. Our equation is y equals A times cosine B times parentheses x minus C plus D. Well, if we just replace these things with what we know, A is 2.7, B is pi over 6, C is 8, and D, actually D is 2.7, I apologize for the mistake, and then A here is 0.9. So make sure you got that fixed there. A is 0.9, and D is 2.7. So we have our equation, which means we can take this part of our instructions and it's done. So we no longer have to do that part. Now we still have to sketch a graph. Okay guys, so when we start to sketch our graph, I'm going to basically sketch an idea of this function and then put the numbers along the axes in order to just label the picture that we have. So we first just start with our x and y axis, and we know that we have this is the beginning of our period, this is the end of our period, this is halfway between. So we'll either have a maximum, minimum, maximum, or a minimum, maximum, minimum. And then we have our minimum, our maximum y value, and our minimum y value. And then right in here is where we'll have our axis. So we have our axis. Now in reading our problem, we notice that the low tide occurs first. So we have our minimum point. And then a high tide occurs, which means we're then going to be going down to low tide. So we started at low tide, went to high tide, and we got to come back down to low tide to show one full cycle. And now we connect the dots, and we have a basic sketch of our sinusoidal function. And now we can go ahead and label where all the values are across the x and the y axis. We of course start with the axis of rotation, which is 2.7, and then we show our amplitude, which is 3.6 is our maximum. That's 0.9 higher than 2.7, and then 1.8 is our minimum value. And then we will label across the x-axis. So we know that our first minimum occurs at x equals 2 hours, and we know that our first maximum occurs at x equals 8 hours. And since it's 6 hours from minimum to maximum, that means it will be 6 more hours to get back down to a minimum. So our last minimum will be at 14 hours. And here we have successfully created a sketch of this function. Now we have to give the depth of the water at 21 hours, at x equals 21 hours. So what we got to do is take this equation and we got to solve for when x is equal to 21. And whenever I do that, I type it in my calculator. I want to make sure my calculator is in radians. And then I'll get y equals approximately 3.97 meters. And I can show you that on the calculator. It'll be the basic calculator. But we have here 0.9 times, well, let's clear that out. Okay, so we got to start from the inside, since this is 21 minus 8. Then we got to multiply that by pi divided by 6. Well, this calculator's not really working for me. So let's take pi divided by 6. Pi. Oh, well, I see the problem here. My first issue here is my calculator is in degree mode. Now I need to make sure it's in radian mode. So pi divided by 6 times 21 minus 8. Then we're going to take the cosine of that value times 0.9. And then we're going to add 2.7. And then we get, ooh, it's actually 3.479. So my memory was not very good. So 3.479 meters is the depth of the water at 21 minutes.